Okay, so here are some examples of the 3 plus 3. And we know that there is an easier way to do 3 plus 3. What's another way to represent 3 plus 3 plus 3? 3 versions of 3. Can we simplify that down? Not 3 squared. 3 times 3. And some of that is represented in the picture. So here we have 3 groups of 3. So 3 groups of 3 is the same thing as 3 times 3. Now, well, it ends up being 3 squared, but that's something else. So if you look here, I don't necessarily see 3 times 3 here, but I do see 3 times 3 above. So let's look at the next picture. Do you see 3 times 3 in the answer here? So obviously we have 3 groups of 3, but in the answer, do you see 3 times 3? I'm seeing some nods. How do you see 3 times 3 in the answer? 3 rows and 3 columns, which gives me 9. And the same thing is shown here. Okay? Well, if I had 3 times 4, could I represent 3 times 4 in a picture? So B is actually 3 plus 3 plus 3 plus 3. And we get lazy, and we say 3 times 4. So do you see 3 times 4 in the picture? How? So we have 4 boxes, and each box has 3 x's. So that would be 3 times 4. So do we see 3 times 4 in the answer? How? 3 rows and 4 columns. Okay. So you didn't quite get finished with that, did you? Okay. So now looking at 4 times 5. Do you see 4 times 5 in the picture? 4 versions of 5. Is that the only way to do that? We could have 5 versions of 4. So we could draw and put 4 in each box. So 4 times 5 is either 4 versions of 5 or 5 versions of 4. Okay? So what about the squared versions? What does it mean to square something? So your next box is 2 squared. What does it mean to square something? Multiply it by itself? Okay. So go ahead and give a attempt at 2 squared, which is the easy one, and then move on to 2 to the third. And just to help you out, what is 2 to the third? 8. So your second picture should have 8 boxes or dots or people or whatever you're looking at. So here are some examples. Shonda, can you explain what you did in part D? 2 times 2 is 4. Does anybody see 2 squared in the picture? It's a square. And how big is a square? 2 by 2. So if I had 2 to the first, that represents one picture. And if I'm going to square it, I'm going to take what is there and double it, because it's 2 times 2. I'm going to square the 2. So this is a square built out of 2's, which has 4 inside of it. Okay? So Tegan did the same thing, 2 squared. Now here, we have 2 times 2 times 2. Right? And this is not addition. If it was addition, 2 plus 2 plus 2 would be 6. But we know that 2 times 2 times 2 is 8. So here is my original 2. And I'm going to double my original 2. And that's where I get my square. Then what am I going to do with my square? Double it. So I should have, in this picture, I should have 2 of those. Do I? Yeah. So in this picture, I should have 2 of those. Is that what we have? So in the original picture, I can separate this into, that's my first 2. And then here is my square. Let me use a different color. Here is my 2 times 2. And then here is my 2 times 2 times 2. Can you say, I took my original, I doubled it, and I doubled it again. So what would the next picture look like? Would it have 16, and how should I arrange it? Where would you put those other 8 boxes to keep the pattern going? I would put it underneath and create a square. So I would have 16 right there. And then you can see the original 2, double, double, and then double again. Okay? That's a great way to do it. What did you do, Tegan? It's a cube. Where did you get the idea of a cube? 2 cubed, right? So can I see the 2 times the 2 times the 2 in this picture? So let me see if I can do it. Here are the original 2. And I doubled those, which created this square. So the first 2 is accounted for, the second 2 is accounted for, and the third 2 is doubling towards the back, and we would have this picture. And again, there are lots of ways to do this. How would I do 2 to the 4th? What would I need to do? How could I extend this picture to represent 2 to the 4th? Put another 8, an 8 squared cube. Does that make sense? So I could put another. And then how would I do 2 to the 5th? I'd copy all of this and maybe put it to the right. And how would I do 2 to the 6th? Copy all of that and put it perhaps at the back. Okay? Good? So now I want you to consider 3 squared and 3 to the 3rd and 3 to the 4th. So this time we're not going to be doubling, we're going to be tripling. The other. All right. Can you explain this, Skylar? Oh. Sorry. How about that one? So I should have a 9, right? So explain how these 9 circles represent 3 squared. So what is what is this? And what's that 1 for? 3 to the first. Okay? So I take my 3 to the first, and I'm going to do what to it? I have my original 3, and what do I do to that? Triple it. So I should end up with 3 versions of my original 3. So here are the 2 extra 3's necessary. So 3 versions of 3 is 9. Great. So if we were to combine those, we would end up with this one. So 3 versions of 3. So every time I add an exponent, I'm going to triple my picture. Okay? So here, we have 3 times 3 times 3. So here is my 3 by 3. And what do I need to do to this picture to create 3 to the third? Triple it. Do you see 3 of these in this picture? Yeah. Here is the first set, here is the second set, and here is the third set. Are you wondering why on earth we're doing this? Okay, just hang on. So, we're not quite finished with it, but what is this picture going to look like? If she were to continue, so here was my 27. What am I going to do to my 27 to get 3 to the fourth, which is 81? Triple this picture. So just like the first picture, I'm going to triple it. In my original, I had 3 dots, and I tripled it to get 9 dots. But when I got to 3 to the third, this was actually 27 dots. And I take those 27 dots and I triple it to get 81. Do you kind of see the pattern? Okay, that's one way to do it. Here's another way. Do you see 3 to the third in this picture? My original 3, and I square it, which means I add those. And then what do I do to those 9 boxes? Triple it again. So I'm going to add this whole row onto the back and this whole row onto the back. Okay? If I were to continue this picture and write 3 to the fourth, what would it look like? I would have 2 more cubes. And that would equal my 81. Okay? And that's, I mean, again, that's kind of hard to draw. Okay. Justin, Skylar. All right. Why on earth did I bother with all of that? Well, a couple things we need to remember. 4 plus 4 plus 4 plus 4 can be simplified. Let's do one more. How do we simplify that? 4 times 5, or 5 times 4, it doesn't matter. But what about 4 times 4 times 4 times 4 times 4? 4 to the fifth. My base is 4, but I have 5 versions of them. Okay, what if I did 4 to the third squared? What is that? Well, what's another way to write squared? 4 to the third times 4 to the third. So if I had 4 to the third times 4 to the third, which rule does that follow? Which rule could I use to write out all of the 4s? Am I going to write them out using multiply, or am I going to write them out using addition? Multiplication. So this is really 4 times 4 times 4 times 4 times 4 times 4, which is 4 to the 6th. Okay, good. Here I could add the exponents, right? But what about here? Distribute using multiplication. Yes. So if you have two bases that are the same and you're multiplying, you can add the exponents together, which is all we did here. 1 plus 1 plus 1 plus 1 plus 1 is 5. Okay? So if you're adding, you can combine addition using multiplication. If you're multiplying, you can combine by adding the exponents, as long as the bases are the same. If I had 4 to the 3rd and 3 squared, I can't combine that at all, because I have 3 versions of 4 and 2 versions of 3, and I don't have 5 versions of any one thing. So that can't be simplified using these rules. But another important thing is, if I have 4 to the 3rd squared, this is just telling me I have 2 versions of 4 to the 3rd, which is the same as 4 to the 6th. And that's going to be important. Okay. So let's look at part J. So in 2 to the 3rd, there are 2 ways to draw 2 to the 3rd that we looked at. Oops. Let's do a better job than that. Okay, that's one way to do 2 to the 3rd. The other was to do this. So draw whichever picture you prefer. It doesn't matter. Okay? And remember, inside this 2 to the 3rd, we have 3 2's, 3 doublings. And I'll circle them. So the first 2 is there. I take those 2 and I double it. Then I take that double and I double it again. So, down below it says, what would 8 to the 2/3 be? Now, wait a minute. Can you have a fraction exponent? Sure. Okay, this is 2 to the 3rd. We have 3 doubles. What would it mean to take 8 to the 2/3? So if I look at this picture, if I look at my picture of 8, and I want 2/3 of 8, what is 2/3 of 8? Well, if we try that on our calculator, 2/3 of 8 is some terrible decimal, right? 8 times 2/3 would be 16/3, which is 5.3 repeating. But we're not taking 2/3 of 8. We're taking 2/3 of the doubles. What would 2/3 of the doubles be? Well, I have 3 doubles. I have my original double, and I doubled that to get 4. And then I doubled that to get 8. So I would only look at the first 2 doubles. What is the value of the first 2 doubles of 8? 4. I take the first of 3 doubles, and I take the second of 3 doubles, and the answer is 4. Wait a minute. That doesn't make any sense, right? Okay, let me turn on my calculator. If you have one, pull it out. So if I tried to take 2/3 of 8, 8 times 2/3, I get a decimal. But that's not what we're doing. We're taking the 2/3 power, the 2/3 exponent of 8. So 8 raised, and you might have to put parentheses around it. If your calculator does 8 with a up and then 2/3, you don't need parentheses. But if it doesn't, then you need to do 2/3 like this. I get 4, which means if I break 8 into 3 multiplications and I take 2 of those multiplications, I get the value of 4. And you've never seen anything like this before. So 8 is actually 2 times 2 times 2. And a lot of you put that on in your pictures. If I split 8 into 3 equal multiplications and I only take 2 of those multiplications, then I get 4. Okay? So there's a difference between 8 to the 2/3 and 8 times 2/3. This is using multiplication, and this is using addition. If I had 6 and I times it by 2/3, that's saying 2 plus 2 plus 2, and I take 2 of the 3, I would get 4. 2/3 of 6 is 4. But if I break 8 into multiplications and I take 2 of those 3 multiplications, I also get 4. So you need to know the difference. Is that confusing you? No? Confusing you? So you need to know the difference between 4 plus 4 plus 4 and 4 times 4 times 4. This is 3 times 4, and this is 4 to the third. If we multiply them, that's just another form of addition. If we are using an exponent, that's another form of multiplication. So what is 2/3 of this? So the answer is 12. If I took 2/3 of 12, I get 8, because 4 plus 4 is 8. This is 64. What is 64 to the 2/3? 16. I'm taking 2 of the 3 4s, which gives me 16. Okay, let's look at the next one. So draw 3 to the third. So I'm just going to draw one picture. You can draw whichever one you want. So there's my original 3. I'm going to triple it, and then I'm going to triple that. So that's 27. So 27 to the 4/3. That's a problem. Anybody see a problem to this? Say that louder. Do we have 4 triples? How many triples do we have? 3. So I have my first triple here, my second triple there, and my third triple here, and it says keep all of the triples and the next triple. So what is the next triple going to look like? It's going to be 3 versions of 27. So how many is going to be in that group? 81. So let's try it. 27 raised, and I don't need parentheses, but you might. Oops, 27 raised to the 4/3 is 81. So it's just saying, can you break 27 into 3 multiplications? So this bottom number says, can 27 be broken into 3 multiplications? Yes. How big is each multiplication? Is it a double or a triple or a quadruple? A triple. So if you have 4 triples, how big is it? 81. What if I did 8 to the 4/3? Can 8 be broken into 3 equal multiplications? Something times something times something. Is that possible? 2. What times itself is 8, and that's 2. So this is saying 8 is 2 times 2 times 2. How many 2's do I need to complete the answer? 4 of them. Times 2, which is 16. So if I did 8 raised to the 4/3, I would get 16. Because I have 3 doubles, and I need 4 doubles for my answer, and 4 doubles is 16. Okay. Now we don't really want to draw the picture for this one because it's humongous. But can 81 be broken into 4 equal multiplications? So I need something times something times something. So do I have a number, something times itself times itself times itself, that's 81? What is that number? 3. So 3 times 3 times 3 times 3. How many of those 3's am I going to keep? 3 of them. And what is 3 to the 3rd? 27. What if it said the 5/4? How would I find 81 to the 5/4? I would add another 3 to the end, and it would be 81 to the 3rd, which is, I don't remember, 240, 243? 243. Okay. So your homework tonight is working on this set. Ignore the examples. We'll do the examples tomorrow in class just to make sure that you know how to do it. But these problems, 6 through 21, the answers are on the back. Okay, so just do 6 through 21. And we're going to have a book assignment today, but we won't. Yes. Yeah, if you have yesterday's assignment, turn that in, please.